we're going to look at another related rates problem here. And it says sand falls from a conveyor belt at a rate of 10 meters cubed per minute onto the top of a conical pile. The height of the pile is always 3/8 of the base diameter. Okay, so let's kind of draw a situation of what's happening. We've got this conveyor belt, right? The sand, I don't have anything the color of sand, I guess we'll have to use gray. So sand is going down this and falling onto something and making a pile. That's a cone. Okay. Now, we're going to be talking about the volume of a cone here, and the volume of our sand cone, the volume of any cone is 1/3 pi r squared h. Okay, so we're going to use that. So we've got our volume. We're going to have dV dt, which will be the rate the volume is changing, which we're told here that it's 10 meters cubed per minute, right? And that's the volume, because if you think about it, what is the volume? It's how much sand is in that cone. Now what we're going to look for in this first part is how fast is the height changing. So we're going to be looking for dH dt. Now we're also told that the height, h, is always 3/8 the base of the diameter. So if we think of a cone, right, we've got this base which has a diameter, which would be 2 times the radius. And then we've got the height, and we're told that the height equals 3/8 of the diameter, which means the height equals 6/8 of the radius if you plug in 2r for the radius, and this would reduce down to 3/4 times the radius. Now that also means if we want to get it that 4/3 times the height equals the radius if we multiply both sides by 4/3. So if here we want to know about the height, we're going to want to get the volume equation just in terms of the height. So for r, we're going to plug in 4/3 h. So we'd have 1/3 times pi. Squaring the 4/3 would give us 16/9 h squared times h. So this would give us 16/27 pi h cubed. So if we take the derivative of both sides, we'd have dV dt equals, if we take 16/27 times 3, and we reduce that, we get 16/9 pi r squared, and then we have to multiply by dr dt. Oops, sorry, that should be an h. H squared dH dt, which dH dt is what we're trying to find when h is 4. So we were already told that dV dt is 10, so we're going to have 10 equals 16/9 pi times 4 squared dH dt. So here what we're going to have is 10 equals 256/9 pi dH dt. So if we solve for dH dt, we're going to have 90/256 pi. So the rate that the height is changing is approximately 0.11 meters per minute. Okay. Now, what if we're asked for how fast the radius is changing? Well, here we're still going to be talking about the volume. But now we would just want to get the volume in terms of the radius. And we know that the height is 4/3 times the radius. Or sorry, 3/4 times the radius. So we're going to plug in 3/4 here. Now if we simplify that, the 3's cancel out. We have 1/4 pi r cubed. So we're going to have dv dt equals 3/4 pi r squared dr dt. Now we know dv dt is 10. And we're looking for dr dt. Now this says when the pile is 4 meters high, that's our height. And we need to plug in an r radius. So we need to figure out if h is equal to 3/4 r, then if we plug in 4 there, we'd have 16/3 equals the radius. So we're going to have 10 equals 3/4 pi 16/3 squared dr dt. This is going to give us 256/9. And we can make that a 3, cancel that out. We can make this 64. So we're going to multiply by 3/64 and divide by pi. So we'd have 30/64 pi equals dr dt. So dr dt is approximately 0.16 meters per minute. Okay, so you can see sometimes if you have more than one variable in an equation, you'll have to first find another equation that relates to those variables and first do a substitution so that you only have one variable when you're taking the derivatives.